Hi again, welcome to our next lab, that is relief displacement on aerial photographs. So in this lecture we talk about the how relief displacement is created over a aerial photograph. So as we know that when we take a photograph with a single camera, it will cover an area with central projection. Okay, central projection means the rays will be projected from a center, that is your camera aperture, and it will cover an area like this, and this will be your exposure and this will be your coverage angle. Okay. So as we talk about that, the midpoint of your aerial photograph is your principal point. In a true vertical aerial photograph, the principal point and the nadir point coincides. Okay. What is a nadir point? Nadir point is a point vertically below the lens, camera lens. Okay. So when there is a true vertical aerial photograph, your principal point and your nadir point will coincide. So this means the objects which are located near the principal point or near the nadir point will be represented in true dimensions, like there will be no distortion in their appearance. It will look like this, like you will see the camera is looking from a point, an exposure station in the air, and it will cover its top. Okay. And this feature is shown as an square. Okay. If the top of the building is of a square shape, then it will be in square shape, and whatever shape it is, it will represent the true shape of the top of the building. But suppose when there is a building which is located away from the principal point or nadir point, this will give you a difference in the appearance, like it will cover this building from this portion only. Okay. And you can see this building leaning away from the principal point. Okay. Leaning away from the principal point, but in actual position it will be like this only, but because as it is located away from the principal point or nadir point, it will be look like this, leaning outward from the principal point. So as we look an object with our eye also. Okay. So this is, suppose we close our one eye and look over an area with a single eye. So we will have central projection in that case, but when we look with our both the eyes, then it will give us an overlapping area. Okay. We can view a terrain in 3D also. Okay. So, that important because we can see each and every object. If we see the objects from the top also, we can see the real dimensions of the buildings and all the objects on the surface of the earth, okay, with our both the eyes. But in case of camera, there is a single lens, then there will be a central projection. If we take the same area with the two different lenses, this will also give us true dimensions of the buildings and true positioning of the objects. So, what is a relief displacement in terminology? It is the radial distance between where an object appears in an image to where it actually should be according to a planimetric coordinate system. Okay. So, the images of ground positions are shifted or displaced due to terrain relief in the central projection of an aerial photograph. So, what causes this? This can be due to presence of relief. Okay. This may be due to some error in photography also, some tilt, some drift, and number of factors while the aircraft is moving, is flying over the terrain and capturing the photographs of the area, okay, as we discussed in the line of flight lecture. So, the relief displacement under the following principles, like as I talked earlier, the objects will tend to lean outward, radially displaced, okay, away from the center like this. Okay. The taller the object, the great relief displacement. The further the object is from the principal point, the greater is the radial displacement. Okay. So, this in this case of aerial photograph, this will be your radial distance. Okay. This will be your height of the object, this will be your radial distance. So, when the radial distance is greater, there will be more relief displacement. This is directly proportional to radial displacement. One can notice that except for the features on the nadir point or the principal point, as you can see here, in this case of aerial photograph, this will be the fiducial marks on these photographs on all the four edges, on the midpoint of the edges. So, this will be the line joining the fiducial marks will be your principal point. So, at principal point or nadir point, you will see the true positioning and true dimensions and true image of the objects or buildings. Okay. Buildings are perceived under a certain angle, and that this angle changes depending on the location in the image. So, this building is located at the corner away from the principal point at a greater distance, it will have more relief displacement in terms of its length as measured on the aerial photograph. This is little closer to principal point or nadir point. So, it will have lesser relief displacement in comparison to building number 2. So, one will have lesser relief displacement. Similarly, this. So, all the buildings which are radially located outward and placed at a greater distance from the principal point will have more relief displacement. This is the concept of relief displacement. Hope you understand it from this figure easily. A vertical object such as building, for instance, will appear to be lying along a line radial to the image nadir point. This deformation is called relief displacement. Okay. So, here this is your radial line, and it shows like this, that This object, the buildings are located, positioned parallel to this radial line. Okay. So, this is the effect of relief displacement. You can take a look over this aerial photograph, area 1, this is window 2, this is window 3. Here you can see that here there are series of buildings, okay, these, okay. So, these buildings are located here. So, you can see the base of the building is this line marks the base of the buildings, okay. This marks the top of the building, base and top. So, in case suppose if this building is located at the center, so you will see it in a form of a rectangle, because the shape of its terrace is rectangular, but it is located radially outward from the nadir point. So, this is the reason behind the displacement of its terrace from its base of the building. Okay. Similarly, at this place also you can see, because there is some relief, some ground relief at location window 2. So, here you can see that this road is going like this. Okay. So, it is showing some kind of displacement on the image. In window 3 you can see this building very clearly, this building. Okay. So, you can see the base of this building here and top of this building here. Okay. So, this is another advantage over the vertical aerial photograph. We can calculate the height of the objects by applying the relief displacement in addition to flying height, that is capital H. I will explain on the next slide. So, you can see some remarkable things about the position of the top and bottom of the buildings on this image. Okay. Why these positions are changing? It depends on the location of these buildings, as I discussed earlier. Okay. So, suppose this aircraft is flying over a terrain here. Okay. It is capturing this area like this. Okay. So, A is the image nadir point here. So, what will happen here? When an aerial photograph is taken, there will be some deformation visible in the way the features are depicted on the image. The further away a feature is from the image nadir point, the bigger this deformation will be. The image nadir point is the point located on the surface exactly below the perspective center. What is the perspective center? I discussed it earlier. The perspective center, or the camera lens, the point vertically below the camera lens is your perspective center. It is called the nadir point. So, the relief displacement can be hundreds of meters. For example, like ICNO satellite data, you can see the sensor requires some image data for an area with a kilometer of vertical relief. Okay. So, with the sensor having an elevation angle 30 degree from nadir point. Okay. So, the image product will have nearly 600 meters of relief displacement when it is having an elevation angle of 30 degree from the nadir. So, then in that case the displacement will be nearly 600 meters on the image. Now, how we can derive the formula for relief displacement from? First thing you have to remember that the relief displacement we can visualize over a single vertical photograph. Okay. We do not need a stereo pair for it, because it is a radial defect. Okay. So, we can identify it on a single vertical aerial photograph also. So, as you can see the geometry of this photograph here, this is the building, this T point is representing the top, this B is representing the bottom of this building and H is the height. Okay. So, here this is the plane of projection actually where your camera is located, and this is your negative film area, okay, where you can have the image of this ground. This is the real ground. Okay, you can have the image of this ground over here. This is the focal length, and as you know that the scale of a photograph is f by h, where f is focal length and h is the altitude at which there is flight. Okay. So, the magnitude of the displacement in the image between the top and the bottom of an object is its relief displacement, and this is related to the height of the object, number 1, number 2 the distance from the nadir point, and we can derive the expression like suppose this x is your perspective center and y is image nadir point. We can derive an expression. How we can derive expression with this geometry, I can explain in a very simple way on the next slide. So, what happens actually when you see your ground, it will appear like this, okay, and in this ground, so this is the relief of the ground. Okay. So, this is at this point A, there is elevation of some 12 meters suppose, and at this point B there is a depression or a basin like structure. Okay. You can say that minus 10 meter, and because we are considering this line as our datum surface, you can say it datum surface or datum plane. From this 0 line, this is below this datum surface, and this point A is above the datum surface. So, if we take photograph of this area like this, so suppose this is the ground and the photographic principal point is lying here. Okay. So, this is your lens and this is covering this area like this. Okay. Similarly, you can get your photograph like this. Okay. So, at some point here, this will be your principal point on the photograph. So, what happened? There is a elevation change on the topography. From the center of the photograph, we can see the point which are located at a higher elevation, it appears like they are leaning outward from the principal point, but the depressions over an area, they are in the form like they are leaning towards the principal point. Okay. So, this is the difference of relief, okay, which controls the amount of relief displacement over an aerial photograph. So, another important thing, how to derive measurement for the relief displacement in a simple way. So, now after having an understanding of relief displacement, let us try to understand it in a very simple geometry, so that you do not have any confusion while doing your practicals. So, suppose this is your ground. Okay. Let us draw this ground lower. So, this is your ground which is taken by the lens mounted on a camera. This is the altitude of your camera. altitude of your flying height, you can say. This is your datum surface, simply datum, and suppose this is a building over this plane. So now you have to map this building, you have to cover, you have to understand the relief displacement with the help of this object over this photograph. So this is your ground, there will be a photographic negative, okay. So a simple geometry, the rays will go like this, okay, and at one part it will cover its top, the top of the building. So this point on ground is A, this point is on ground is B. So here this point small a and this point small b. So these two, small a b represents capital A B, okay, the location of these points. So this is your lens and this is of course your focal length from here to here. So what you can do, suppose the height of this building is h, this is over ground, okay. So this capital D represents the coverage of this building over ground. So this will be small d here from point A to B, okay. So this capital D is represented by the small d on the photograph. This will be your principal point on the photograph here, and the corresponding point is this on the ground. So this is this distance actually from this here to here, this is your capital R, okay. And similarly from principal point to the last point of the building covered over ground, that is capital B, here to small b, this will be your small r, okay, small r. So the capital R is represented by small r over the photograph. So this you know well that the relief displacement varies with the height. So first thing we know is, suppose we say relief displacement as RD. So relief displacement is directly proportional to the altitude, the capital H. Why? From if your lens is here, so suppose a building is located here at the center of this photograph or at the nadir point, means the points directly below the perspective center, which is your lens. So this will be represented in a true shape. The top of this building, suppose this is of rectangular shape, so from whatever height you will see it, this will be shown as the same shape, okay, that is rectangular. So what it means, the points, the objects or the buildings which are located at nadir point or directly below the perspective center will have no relief displacement, okay, will not be affected by the relief displacement. So what it means, that when an object or a building is located away from this point, okay, away from this point, so the relief displacement will be more. So this building is represented over your photograph here like this, point A to B, because photograph is a two-dimensional plane So, you can see this building, but in a little what different manner. You will see your building like this. So, it will be covering some of the area over the photograph. Okay. So, what it means that relief displacement is directly proportional to this distance, this r, capital R. So, what is this? This is your radial distance. Okay. So, what it means that relief displacement is directly proportional to the radial distance r between the displaced image and the principal point. So, here this is directly proportional to your r. So, because we are talking in terms of the photograph, so we are taking here small r. Okay. Number 2, so suppose the same building that we are looking from this distance, from this altitude, and the same building we are looking from this altitude. Okay. What will happen? This will have more coverage over the photograph. Okay. This building will have more coverage over the photograph. It means that the radial distance of the end point of this building, suppose this is the end point. So, the radial distance from the principal point to the end point of this building will increase as we move below, okay, as the altitude will decrease. So, what it means that relief displacement, when altitude is decreasing, the relief displacement is increasing. So, it is inversely proportional to your h. And point number 3 is that one thing, the relief displacement is directly proportional to the difference in the elevation of an object h. So, this object or this building is having height h. Okay. So, when the height of this object or building increases, so then it will result into the greater relief displacement. So, what it means? As this h small h increases, relief displacement will also increases, because the taller the building, the larger area on the photograph it will cover. Okay, you understand here. So, we got to know from here that relief displacement is also directly proportional to your small h. So, from this understanding, what we have now, we can express our relief displacement formula as relief displacement is equal to small r, that is radial distance, and h divided by capital H. Okay. So, from here we can also calculate the height of a building. So, relief displacement is of course a defect on the photographs, but with the help of relief displacement we can calculate height of the buildings or height of any object. How? We can replace this h from here, like h will be equal to, suppose relief displacement is capital R D into h by your r. Okay. So, this will be the formula for calculating height of an object. Okay. So, what we got to know, that relief displacement directly proportional to radial distance of the object from the principal point. Number 2, relief displacement inversely proportional to the altitude of the flight, altitude of the camera lens. Okay. And the last one, relief displacement is also directly proportional to the height of the objects. So, it will be explained on the next photographic example that is taken to explain you the calculation of the height of the objects over the aerial photograph. So now we are going to move with our relief displacement exercise. So how to do a practical to calculate the relief displacement or the height of the objects with the help of relief displacement, if you know. So this we will do with other type of photographs. Okay. So as you know that in the previous exercise we were looking over these photographs, okay, aerial photographs. So now let's have some other kind of photograph. Okay. So as you can see here, this is an UAV. Okay, UAV means unmanned aerial vehicle. So this can take photographs of the ground in the same manner a satellite or an aircraft takes. Okay, so this, with the help of this UAV, you can also take photographs in a sequence along a line of flight. Okay, the overlapping photographs. Okay, these are the wings. Okay, so this is model. This model is known as Phantom Pro, and here the lens is placed. Okay, so this is a lens having a high magnification, okay, and a high power, which can look over the ground and capture ground from a greater height also. So example of the photographs taken by this UAV very recently, these 4 photographs are the examples of the aerial photographs taken by this UAV. Okay, so let's work with these photographs to calculate relief displacement or the height of a building. Okay, so let us put this UAV. So now you can see that these are the 4 photographs taken by this UAV along a line of flight. Okay, so this building is the computer center of IIT Kanpur, and in front of this you can see that this is a greenish plantation over here, and this is the parking lot. Okay, and this is the ground. This is another building. Okay, actually we know the heights of these buildings. In case you are having some objects or some buildings for which you need to calculate the height, you can do by the parameters which I explained in the lecture slides, like relief displacement, the altitude, flight altitude, okay, and the radial distance from the principal point. Okay, so for this photograph, what will be the principal point? As you know, these are the example of vertical photographs, because UAV fly in a parallel manner, okay, without going up and down. Okay, if there is no strong wind, then there will be no distortions in the images, and you will get the planar projections of the images. Okay, and the lens will work as a central projection from where the rays will lie perpendicularly over the ground, and it will pierce the principal point or the nadir point. So in this case, because this is a true aerial vertical photograph, so in this case your principal point, your nadir point and isocenter will coincide. So as these are representing the axis 1, 2, 3, 4. Okay, so you can take the midpoint of the axis like this. Draw a line. It's not visible. So the intersection of this line here will give you the principal point. Okay. So this will be the principal point. So as you know, so when this photo was captured, the UAV was flying like this, okay, at an altitude. So it may be an altitude, whatever altitude, we can set the altitude also, okay. So for this survey we have taken the altitude of 60 meter from the ground. So this ground represents the datum surface, and this the height from the ground. So this will represent your flying altitude, okay. So this we know. So here if you see this, so you know the h, that is flying height, okay. This is 60 meter in this case, okay. And you know the formula for relief displacement. You see, okay, what you learn from the lecture. So that relief displacement directly proportional to height of the objects or anything, any building. Relief displacement directly proportional to radial distance from the principal point, okay. And relief displacement is inversely proportional to flying altitude, flying height, capital H, okay. So with this information we have this formula: relief displacement is equal to h into r by h. So suppose we need to calculate h. So suppose we have here, suppose capital R is your relief displacement, okay, and h into r by capital H. Okay, so this you know. So in case which you need to calculate, in case when you need to calculate your height of the object or building, so then simply what you will do, h will be equal to r into h divided by your r. Let's do it. Okay. So in case when you need to calculate the height of the object or a building, what you will do, you will take your h here and r into capital H divided by small r from here, okay, on this screen you can see. So this will go with this capital R into H divided by R. So here this H represents the height of the object or the height of the building, capital R represents relief displacement, H represents height of flying altitude, and small r represents the radial distance from the principal center. And what is the radial distance from the principal center? You know this. Suppose there is a building located here, and so distance from principal point to the last point of the building where this building touches the ground, the top of this building touches the ground, this will be your radial distance, okay, and this d will be your relief displacement. Sorry, this on the photograph. Of course this is on the ground, but its representation over the photograph will represent the relief displacement. So moving ahead, you know here at this point you have your principal point. So suppose we need to calculate the height of this building, okay, the height of this building. So first what you need to know, for R, H and small r, okay. H, you know, capital H is 60 meter, the flying altitude of the UAV, okay, and R is your relief displacement, and what it will be? It will be the distance between the bottom and top of the building. So here we know the bottom of this building is this, and top of this building represented by this point. So we can measure it. You can see it by zooming your image. So this is coming around 2.5. As you can see here, this is coming around 2.5. So what you know now, your relief displacement is 2.5 centimeter, okay. So what other thing you want to know? You know H, you know R. Now you want to know your small r, that is the radial distance from the principal point. So principal point is this, and your radial distance up to the top of this building is, you have to measure with the scale. So it is coming around 11 centimeter, as you can see here, okay. Principal point to the top of this building. So your r is, small r is 11 centimeter, okay. So by putting these values in this formula, you can get your h. So small h will be equal to 2.5 into 60 to multiply it by 100 to convert it into centimeter, okay, and then divided by small r. So that is 11 centimeter, okay, because this is given in meter, so multiply it by 100 to convert into centimeter. So by calculating it, you will get around 13.63 meters, okay, 13.63. You can do this calculation by your own, so you should get it. So by looking this building, you will have an idea that yes, the height of this building should be around this much value, okay. And so because we see this building and we have the information about this building, so we know that the height of this building is coming around in a true manner, okay. So this is with the help of relief displacement, you can do such type of measurement on your photographs. So this topic is covered under the photogrammetry, okay, on which you can do measurements on the aerial photographs. And in the similar manner, you can also calculate the relief displacement. Suppose you don't know the relief displacement and you are having a photograph and you know the height of any object, okay, so you can calculate your relief displacement. The very easy method of calculating flying altitude is with the help of this formula, because in many cases we are having photographs from some area, but we don't know the flying altitude, so we can calculate by putting this information over here, okay. So this is the practical for relief displacement. Okay, in the next practical we will learn about the stereoscopic parallax. Thanks.